Good morning. Today, I will be presenting our project, Application of Radiation Techniques in Geochemical Characterization of Cobalt and Other Valuable Metals in the Selected Metallic Deposits. Critical raw materials are defined as materials that are economically important but have a high risk related to their supply. Examples of these are cobalt and scandium. Cobalt is one of the critical components of electric vehicle batteries. Driven by climate change and energy security concern, many plan to transition to electric vehicles. Cobalt is the only EV battery raw material that is now considered as CRM. It is because it is estimated that from 2023, there will be a deficit in the cobalt supply. Also, in DR Congo, the primary source of cobalt, child labor remains a problem in cobalt mines. This is the reason why EV manufacturers are looking for an alternative source of cobalt. One of the mineral deposits considered as cobalt source is nickel laterite. Luckily, our country has several nickel laterite deposits as shown on the map. But previous mineral resource estimations done by laterite mining companies did not consider cobalt content of their laterite deposit. The project's overall objective is to apply radiation techniques such as LIBS and XRF or X-ray fluorescence in characterizing cobalt and other valuable metals in selected Philippine metallic deposits, which include nickel laterite and other metallic deposits are shown in the map. So these deposits are located in different parts of the country. Our partners for this study are Mount Labo, Mark Ventures, Philex Mining Corporations, Jose Panganiban LGU, MGB Region 3, and MGB Region 5. Geochemical analysis shows that high cobalt contents are present in nickel laterite and Panganiban skarn samples. Nickel laterites and bauxite samples have high scandium concentrations. High copper concentrations are reported in skarns, massive sulfide, epithermal gold, and porphyry copper samples. And lastly, skarn and beach placer samples have high iron concentrations. Summer bauxites also have high REE contents are shown in the table. This study is the first to characterize REEs in the Philippine bauxites. Based on the current prices, the REEs in summer bauxites could be worth $246 to $323 per metric ton, respectively. High uranium contents are also reported in Panganiban skarns. Uranium contents up to 1,000 ppm is detected in an outcrop in Nakalaya. High gold and silver contents are also reported in the waste rocks from Paracali epithermal gold deposit. High concentration of precious metals, palladium and platinum are present in Pulang Daga nickel laterite. To analyze valuable metals in laterites, our handheld LIBS analyzer was calibrated using spectrum standardization method. We also compared the handheld LIBS result with laboratory ICP-MS result. As shown in the table, nickel, cobalt, scandium, chromium, and zinc contents determined using LIBS are close to those obtained using ICP-MS. Results suggest that LIBS can be an alternative to ICP in determining the values of valuable metals in laterites. LIBS can also perform elemental mapping. In this epithermal gold ore sample, gold and cobalt are associated with pyrite and iron sulfide, while silver and nickel are related to chalcocite or copper sulfide. LIBS elemental mapping is helpful in determining the mineral association of critical and precious metals. Based on the results of our study, we encourage the nickel laterite companies to characterize and to recover cobalt and scandium in their nickel laterite ores instead of giving them away for free to the overseas processor. Our revenue from nickel laterite ores could increase by 4 to 11 times if we recover cobalt and scandium. We also invite interested parties for possible collaboration to utilize LIBS in determining valuable metals in their metallic ores. We recommend funding agencies and mining companies to support R&D studies that recover cobalt, scandium, and other valuable metals from their ores using novel solvent. And we encourage government agencies and interested companies to conduct detailed mineral exploration in Pulang Daga nickel laterite deposit and to consider Panganiban skarns as potential sources of uranium for nuclear energy. Especially, the Philippine government approves the inclusion of nuclear program in the energy mix. Lastly, we encourage the government and mining industry to conduct further inventory and characterization of other critical raw materials in the mineral deposits of the Philippines to fully utilize the economic benefits we can get from these deposits. For further details and possible collaborations, please contact me at my email and our telephone number. Thank you very much.